Breakthrough, a tactile robot finger with no blind spots. I'm Steve Belair and welcome to Breakthroughs. Researchers at Columbia Engineering announced today that they have introduced a new type of robotic finger with a sense of touch. Their finger can localize touch with very high precision, less than 1 millimeter, over a large multi-curved surface much like its human counterpart. There has long been a gap between standalone tactile sensors and fully integrated tactile fingers. Tactile sensing is still far from ubiquitous in robotic manipulations, says Mate Seo Carlisle, associate professor in the Department of Mechanical Engineers and Computer Science, who led this work in collaboration with electrical engineering professor Ioannis John Kimis. In this paper, we have demonstrated a multi-curved robotic finger with accurate touch localization and normal force detection over complex 3D surfaces. Current methods for building touch sensors have proven difficult to integrate into robot fingers due to multiple challenges, including difficulty in covering multi-curved surfaces, high wire count, or difficulty fitting into small fingertips, thus preventing use of dexterous hands. The Columbia Engineering team took a new approach. The novel use of overlapping signals from light emitters and receivers embedded in a transparent waveguide layer that covers the functional areas of the finger. By measuring light transport between every emitter and receiver, they showed that they can obtain a very rich signal data set that changes in response to deformation of the finger due to touch. Then they demonstrated that purely data-driven deep learning methods can extract useful information from the data, including contact location and applied normal force, without the need of analytical models. Their final result is a fully integrated sensorized robot finger with a low wire count, built using accessible manufacturing methods and designed for easy integration into dexterous hands. Wow. The study demonstrates the two aspects of the underlying technology that combine to enable the new results. Firstly, in this project, the researchers use light to sense touch. Under their skin, their finger has a layer made of transparent silicone, into which they shine light from more than 30 LEDs. The finger also has more than 30 photodiodes that measure how the light bounces around. Whenever the finger touches something, its skin deforms, so light shifts around in a transparent layer underneath. Measuring how much light goes from every LED to every diode, the researchers end up with close to 1,000 signals that each contain some information about the contact that was made. Since light can also bounce around in a curved space, these signals can cover a complex 3D space such as a fingertip. The human finger provides incredibly rich contact information, more than 400 tiny touch sensors in every square centimeter of skin. That was the model that pushed us to try and get as much data as possible from our finger. It was critical to be sure all contacts on all sides of the finger were covered. We essentially built a tactile robot finger with no blind spots. Secondly, the team designed this data to be processed by machine learning algorithms. Because there was so many signals, all of them partially overlapping with each other, the data was too complex to be interpreted by humans. Fortunately, current machine learning techniques can learn to extract the information that the researchers care about, where the finger is being touched, what is touching the finger and how much force is being applied, etc. Our results show that a deep neural network can extract this information with very high accuracy, said Kimis. Our device is truly a tactile finger designed from the very beginning to be used in conjunction with AI algorithms. Holy smokes! I'll put a link in the description to the full article, and as usual, please like, share, subscribe, and take care.